Ladies and gentlemen, welcome. This presentation was brought to you by the Visionary Society of Engineers. I thank you for giving me the opportunity to share with you and to all electrical working professionals in the field. This presentation will focus on the use of protection for feeder and branch circuit. What purpose does overcurrent protection device serve? Overcurrent protection system protect equipment that reaches a value that will cause dangerous temperature in the conductor. Overcurrent protection device a device that interrupts current in its current limited range, hence creating the protection that is needed. Figure 1 provides an example of an overcurrent protection device. What are we protecting? Electrical protection system shall protect conductor and equipment against the following conditions, such as high ground fault, short circuit, burn down, or fire. Figure 2 demonstrates how electrical circuits are implemented to offer protection for electrical components. Article 240.4 requires conductor to be protected against overcurrent according to their ampacity and require that they are protected at the point at which they receive their supply. This idea can be illustrated by figure 3 in the diagram, where the conductor is protected at the point of receiving power through multiple circuit breakers. Now, the protection of conductors. Conductor other than flexible cords, flexible cables, fixture wires shall be protected against overcurrent in accordance with their ampacity specified in Article 310.15, unless otherwise permitted by 240.4 in the National Electrical Code. The rules that govern conductor protection is required by Article 240.4 is listed below. Overcurrent protection shall not required where interruption of circuit lead to hazard. For example, a magnetic power lift or fire pump circuit that requires no break during operation. The next higher standard overcurrent protection device shall use when selecting protection for circuit 800 ampere or less. Ampacity of the conductor that is protected shall be equal to or greater than the ratings of the overcurrent device 800 ampere or greater. Now, overcurrent protection shall not exceed the ampacity for conductor for any of the following, that is of Article 240.4d, where it should be in the range 18 to 10 AWG for copper or aluminum clad. These conductors specified under this article should protected against an overcurrent protection device that doesn't exceed the value of the conductor. Secondary conductor of a transformer must be protected by an overcurrent protection device when it is either one of these units identified below. That is, a single-phase transformer other than the two-wire type, a multi-phase connected transformer other than the delta type. Transformer should be connected or protected rather by the primary if and only if it complies with that mentioned for the type below, where it is a two-wire primary and two-wire secondary transformer, or a three-phase delta-delta transformer connected with a three-wire single voltage. Fuse and circuit breaker. The standard ampere rating for fuse and inverse time circuit breaker shall determine using Article 240.6a. That is where it is an adjustable trip circuit breaker. The ampere rating setting shall be equal to the adjustable, means if access is restricted. The adjustable trip circuit breaker not meeting the adjustable requirement shall be set to the maximum setting possible. This adjustable current setting is referred to as a long time pickup. Electrical protection system may follow protection under thermal overload, ground fault protection of equipment, and current limiting overcurrent protection device. Thermal overload protection. Thermal device shall not be used for protection of conductor against overcurrent due to short circuit, ground fault, or use of such device permitted to protect motor circuit against overload condition. Ground fault protection of equipment shall be provided for solidly connected Y electric service 150 volts to ground. It is designed to protect line to ground fault on the load side of the service disconnect. Current limiting overcurrent protection device run is one that cut off fault current and short circuit from building up to their full available values. Now, protection of ungrounded conductor. Critically, this one is very important as overcurrent device is required to be in line with ungrounded conductor. A fuse or overcurrent trip unit of a circuit breaker shall be connected in series with each ungrounded conductor. Circuit breakers shall open all ungrounded conductors automatically or manually unless or otherwise. Multi-wire branch circuit, ground single-phase AC circuit, 3-phase and 2-phase system along with 3-wire direct current circuit must be protected by a single pole circuit breaker. Selective coordination of electrical protection system. Electrical system coordination shall provide protection for two of these conditions. That is, coordinated short circuit protection and overload indication based on monitoring system or device. Coordinated overcurrent protection ensures that the action is selective. This means a fault or overloaded circuit is isolated close to the affected area. Figure 6 is a perfect example of how a selective coordination protection system is implemented. The graphics illustration shows us how the fault in the system works to isolate only the affected area versus the whole electrical system. Now, we thank you for taking the opportunity to listen in on this presentation. Please take the opportunity to register on our engineer platform at www.thevisionarisocietyofengineers.com for more information on feeder and branch circuit protection.